What I want to do is zoom in on one of those emerging cryptographic technologies that Steve described, secure multi-party computation. I want to describe what work that I, together with an excellent team at BU, including Lucy, who just asked the last question at the last talk, have done in order to use this technology in practice. I want to convince you that this technology actually has emerged and can be used in specific scenarios in order to solve problems that sort of deal with this fundamental tension that we have in society between about how to use data, the tension between data sharing and data protection. So on the one hand, we know that like data has this immense value. We often hear these terms like data is the new oil. And we know that data science is a fundamental component of the information era and has provided a lot of benefits. This idea of acquiring as much information as you can and figuring out how to extract as much useful knowledge that benefits society from that. And this has been immensely powerful to society. But on the other hand, as we get better at extracting value from data, somewhat paradoxically, it means that people are even more concerned about sharing it in the first place because people have shared data in the past. They don't know how you will be able to combine some seemingly disparate new data sources with things in the past in order to cause real harms. And we know that data breaches can have significant financial, legal, and political harms. And so as a result, people are very averse to data sharing. Bruce Schneier put this well in 2016 when he called data a toxic asset. So this seems to be the fundamental trade-off that we give to everybody in the world when we ask them what to do with their data. Sort of, do you want to treat data as oil, use it to extract all the value that can benefit society, or do you want to treat data as some sort of toxic asset and isolate it in some sort of protected silo away from everyone? The central theme of my talk is that cryptography allows us to overcome this sort of apparent trade-off, that this apparent trade-off is false. We can actually simultaneously extract value from data without ever needing anybody else to see it. And so this is what I want to talk about today. My name is Mayank Varia. I'm a research associate professor at Boston University. And to be honest, I'm probably the last person in the world who you should probably trust with your data. And yet, what I'm going to talk about is how I, together with my colleagues at BU, have partnered with the city of Boston in order to collect the actual wage data from more than 1/6 of the city of Boston's workforce. And we've done this in order to measure pay disparity across gender and race. So we think that this technology is really prime for use. I want to go through sort of the example of what we've done, but convince you of sort of this greater point. And if this technology of protecting data, allowing you to compute analytics over data you can't see, if the only value of it was to allow shady characters like me to get into the data science business, that would be one thing. But I think the real value of it is that it allows you to sort of transform the way that you think about data science. That rather than trying to figure out what are the data sources I can find and acquire and get at my disposal, and then what is the most value I can get from it, you can think about it the other way around. So first you can think of the question of what is the actual information that I want? What is the problem I want to solve? And then what data out there is available that could help me answer the question, and then how do I adequately protect that data while I'm computing? And so as a result, I'm going to talk about this problem backwards. So first I'm going to describe, so sort of from right to left on the slide. First I'm going to describe the city of Boston's interest in pay equity, and then the kinds of data that they wanted to acquire from companies in order to measure it, and then how this secure multi-party computation idea can be used to protect this information not only in transit or at rest, but also while computing. Okay, so my story begins in 2013 when the former mayor of Boston, Mayor Tom Menino, declared that he wanted to make Boston the premier place for working women, the premier city for working women. And in order to achieve this goal, and in part to identify ways to close the gender wage gap, he established a commission, a women's workforce council, that comprises a bunch of leaders of businesses in the city, both big and small, across all sectors of the city's economy, as well as thought leaders and social advocates from the political and academic and other realms. And these folks established a pledge, a compact, which they called the 100% Talent Compact, which they have gotten more than 200 companies across the city to sign so far. So the compact states that any signatory pledges to do three things: to understand the root causes of the wage gap, to use data and evidence-based methods to close the wage gap, and to measure their progress over time to see how they're doing. In this talk, I'm going to focus on that last piece, that measurement part. Under this mantra of, what gets measured gets done, we want to use this measurement so we want to, the compact states that the employers of, that the compact signatories should jointly compute the overall pay disparity across all of the compact signers so that the city overall holds themselves publicly accountable for moving towards a world where we have 100% equal pay for equal work. So here's the portal that we built and that the compact signers use when they submit their salary information every year. You can play with this for yourself by visiting 100talent.org. Remember when you look at it that the talent audience, the target audience for this website are the human resources employees and chief diversity officers at the various signing organizations. So at the top of the page, we request demographic information, counts of the number of employees at the company grouped by gender, race, and job status. This part here follows exactly a form that the Equal Employment Opportunity Commission, the EEOC, requires all companies with more than 100 employees to submit annually. So most of the companies involved in the compact are familiar with both the structure of this form and they have this information readily available. But if we scroll further down this page, we augment this demographic information by also requesting total compensation, salary information, again grouped by gender, race, and job category. So with this information, we can measure not just whether there's an overall pay gap, but also where it appears, whether it appears, say, for instance, for entry-level status employees, whether it appears further up the promotion pipeline, et cetera. And this is important because while all of these problems are bad, they are different kinds of bad, and there are different organizational structures that maybe need to be rectified. So pinpointing the causes of the wage gap is something that our data collection is striving to do. Scrolling further down the page, we see also a table that asks for total cash performance pay, which we request separately from base salary compensation, because there are many industries like finance and technology where that can constitute a very large, a non-trivial percentage of overall end of year salary, take-home salary, and where, again, this is controlled by different organizational processes. And also we request information about tenure, length of service, so that we can identify how these gaps relate to levels of seniority. So even though these tables go beyond the information requested by the EEOC, by sticking with this schema that the employers are already familiar with, we found that this simplified data collection within this company. So this is the information that we request from employers, but the really interesting part of this form is what happens when they click submit. So it turns out that their data goes nowhere, or at least the data in the clear doesn't go anywhere. And what happens is sort of the interesting part of the story. So the text of the compact, that goal 3 about measuring the success over time, this text portrays the balance between privacy for individual employers versus the interest of the city as a whole in being public about how well they're doing. So the goal of this compact is not to shame any individual company, any individual poor performer, but instead collectively as a society, as a community, to learn and improve over time. And therefore, the text states that individual employee and employer data must remain confidential. It's neither revealed to the general public nor even shared with other compact signers. But then the question is, if this information is never shared with anybody, then how on earth do we calculate the citywide disparities in the first place? The compact here vaguely hints at this question by mentioning something about a third party. And the really interesting point here is that is one of trust, that the companies need to figure out what level of trust do they have to put into this third party. How much information can it, or anyone who compromises it, learn about the company's sensitive salary data? So I want to sort of portray this as a kind of spectrum. On the one hand of the spectrum is kind of what I call the trust us model, where maybe this is a third party where you hand your data completely in the clear, and then they have the full ability to compute over it, but also to learn it and do anything they in principle could want with it. This is the model that underlies the cloud computing revolution that has very drastically reduced costs and improved scalability for computing today. This is the model that the pay equity, the Women's Workforce Council initially tried to pursue. They identified a prominent technology company within the Boston area and a prominent university and asked them, would you be willing to collect all of this salary data? But the companies involved, this compact signers kind of balked at the idea of handing over this data to anybody. But even more interestingly, the folks who were pegged to receive this data also balked because they realized the significant legal liability that might ensue if they receive this information and then they lose it. They could be sued by hundreds of employers and thousands of employees all at the same time. So that wasn't going to work. On the other end of the spectrum, there are these emerging cryptographic technologies that Steve described that allow you really not to have to trust anybody. You can hand over encrypted data and it can be processed without anybody learning what's going on. Things like fully homomorphic encryption and functional encryption. Unfortunately, these technologies, at least at the moment, don't quite yet have the performance for use, but actually even more importantly, are not yet at the level of software maturity to be used today. So what we did is this middle ground. Secure multi-party computation, it doesn't have a trust one entity thing or a trust nobody model, but a trust anyone. There are a handful of 2 or more entities, in our case exactly 2, and the system protects all of the compact signers' data as long as at least one of these 2 entities properly follows the protocol. So it's as strong as the strongest link in the chain. And this is where we come into the picture. So in addition to the Boston Women's Workforce Council, we are this second other entity. We came into this this problem in 2014 when Mayor Menino spoke with Professor Azurbastavros of BU and described sort of the problems they were having with trying to collect this data using the Trust Us model. And this sort of began a 3-year expedition for a bunch of us, faculty, students, and software engineers in building a system that the city could use. So the way that secure multi-party computation works is by every single employer sort of splits or shards their data in such a way that each of the 2 pieces that is given to one of the 2, the Women's Workforce Council or us, individually is just a bunch of gobbledygook. It doesn't mean anything. But jointly, together, we can compute interesting functions over the employer's data and reveal aggregate statistical information. So that's sort of logically how it works. Just to make the process, the workflow simpler, we can even just have the companies communicate with just one of us, would say BU, but with some of the data using standard public key encryption techniques encrypted in transit all the way through to the 100% talent, the Women's Workforce Council. And in this way, this workflow looks from the point of view of an ordinary compact signer identically to the way that normal cloud computing works. You just have to talk to one entity and you hand over what seems like your data. But with the crucial difference that with secure multi-party computation, this entity in the middle that receives the data, us at BU, we never see any of the inputs, we never see any of the outputs, and we never know any of the intermediate state during the computation. So somehow, even though we're the most computationally intensive and technologically savvy entity, we're the ones holding a web server, we're also the one that's the least trusted, which is pretty much the opposite of the way that cloud computing works today. So I want to show you very briefly how this technology for splitting data works. It relies on 2 core techniques, randomness and clock arithmetic. So let's just take a really simple example of let's do a much smaller scale calculation with 2 employees at a single company that just want to know the difference between their salaries. So one male employee who makes $9 an hour, let's say, and a female employee who makes $7 an hour. So the way they will do this is by sort of sending to BU and the Women's Workforce Council 2 totally random numbers that don't have anything to do with their actual salary other than the fact that they actually add up, at least in this clock arithmetic, to their real salary. So sort of if it's currently 10 o'clock and then you wait 11 hours, it will become 9 o'clock. So using this sort of clock wraparound arithmetic. And so in this way, neither BU nor the Women's Workforce Council knows anything about these employees' salaries, but what they can do is locally subtract their 2 clocks that they receive, the blue one minus the red one, and learn something like shares of the actual difference. And then BU can hand over its purple clock, just its share of the difference, to the Women's Workforce Council, who now has the information necessary that it can add together to discover the overall pay disparity, this $2 disparity in my example, that existed. And it only learns this information and nothing else. So even though my slide only shows sort of a simple calculation, basic arithmetic, addition and subtraction, involving very small scale data, this technology can increase to much better scale, to much bigger sets of data, even gigabytes worth of data, and it can perform arbitrary computations, arbitrary arithmetic and Boolean operations, from which you can compute anything in theory and reasonable things in practice. So to give you an idea of the performance of secure multi-party computation, I've shown an example of how its rapid improvement over time, over the past handful of years, in computing the advanced encryption standard. So while the advanced encryption standard is something you can compute at sort of gigabyte scale in the clear, we're actually at the point now where we can compute it at the tens of megabytes per second scale using secure multi-party computation. There's still a significant gap in performance between doing this in the clear and doing it using secure multi-party computation. So I'm not at all here to argue that this is a technology that can be used for like blindly for anything, but it is. But this overhead is something that is manageable for things where the value to be gained is high enough, and the sensitivity is such that it would either be cost prohibitive or just flat out impossible to acquire data in the clear. So basically my point is, even though the performance is a hit, I don't think it's the main impediment to use. I think usability of software for secure multi-party computation is the main impediment to using it today. And so that's been our focus. We've designed an interface that is familiar to our target audience using a spreadsheet interface that HR employees and diversity officers use on a day-to-day basis. It's accessible. It follows Nielsen's 5 rules of usability, and we've had an independent heuristic evaluation by human factors experts to improve the software. It's reviewable so that we can identify if any, there's like on client side, we can identify if any contributor is about to make a mistake in data entry, say rather than entering that they have one employee who makes $100,000, entering by accident that they have 100,000 employees who make $1. Because we don't actually see any of the data, we can't correct for that in post-processing. Ergo, it's important that we have a lot of these visual indicators to users to know if they're about to make a mistake. And it was also important that our technology was actually very simple from a coding perspective. You see our first iteration of the software used about 300 lines of code so that the technologically savvy companies amongst the compact signers, the Raytheons and State Streets of the world, could very easily verify that it's doing what we said it does. Another component of our usability is sort of explaining the software and how MPC works to all of our target employees at the compact signing institutions. So here's a picture of one of our many in-person trainings. We also had online trainings and phone-based conversations with the compact signers in order to teach them how to use our website and how MPC works in general. By explaining to them our website and walking through an example with fake synthetic data, we again minimize the chance of data entry error, which was important to us because we don't have the ability to correct afterwards. And by explaining MPC to them, we increase the contributors' trust in the system, and therefore we believe that helps to drive adoption. And also to put legal departments at ease, that this technology is adequately protecting this sensitive data. At least for the most part, putting the lawyers at ease. We had a fun story where, so our data collection process began on June 8th, 2015. The relevant point here is that's a Monday. On June 6th, which was a Saturday, one of the compact signers decided they were really concerned and they weren't quite sure about our mathematical sophistication. They didn't know if it would adequately protect their data, and they asked us to sign a non-disclosure agreement. So on a Saturday morning, Professor Azarbastavros at BU has to call up the president of Boston University, and then in turn loop in the chief legal officer at BU and have a three-way phone call on a Saturday morning in which Azar described this multi-party computation technology and why this NDA is actually a safe thing to sign because we at BU do not learn any interesting information. And they, to their credit, the legal officers at BU signed off on this. And I think that's really cool that we were able to get our our legal team to sign off on something that the folks who tried to be the collectors of this data in the clear were not able to get their legal teams to sign off on. So that's how our software works. Then all we had to do was sit back and wait for people to use it. We've had great success, and we've deployed this software 3 times in 2015, 16, and 17. The first collection was just kept internally, the results within the Women's Workforce Council, so even I don't know what it says. The 2016 collection, the results are publicly available on the boston.gov website. The 2017 collection information should be there, I'm told, within a week or so. We've gotten buy-in from a number of employers. More than 100 of the compact signatories contributed data to the most recent collection. The information covers about 1/6 of the Boston workforce, comprising about $15 billion in collective wage earnings. We've got great press from, great response, I should say, from the government officials. Here's an example of a quote from the current mayor of Boston, Marty Walsh, who is ecstatic about MPC being used as a groundbreaking moment in tackling the wage gap. And a quote from Representative Catherine Clark from the 5th District of Massachusetts, who likes MPC as a thing that connects 2 of her passions, wage equity and promoting basic research in the sciences. This is a technology that's being used, being considered for use within the federal government. There's a bill pending in the Senate, sponsored by Senators Wyden, Rubio, and Warner, about providing prospective college students with data about the earnings and accumulated debt of recent graduates of those colleges, so that prospective students can decide whether to go. The law specifically states, the bill, specifically states that collection would have to use secure multi-party computation or something of equal or greater security for the individuals whose data is provided. And also there's a bill that has passed the House, sponsored by Speaker Ryan, that indicates that it would require the government to use privacy-enhancing technologies when collecting data for evidence-based policymaking. So I guess my takeaway is, if it's good enough for the federal government, it should probably be good enough for you too. But on a slightly more serious note, I have sort of 2 takeaway points. My first is that I encourage you to use MPC within your own organizations. For selected uses, it's actually a mature technology that's ready to be deployed in cases where data is simultaneously an object of great value and an object that is very toxic and needs to be protected. And second, I urge you to be skeptical when you hear people peddle this false choice between knowledge and privacy in order to get you to do things that really seem to sound like they serve their own end purposes, such as when you hear companies tell you that you have to hand over a lot of your sensitive data just in order to receive some sort of simple service in response, or when you hear people cite privacy or confidentiality concerns as a convenient excuse to deny society the answers it wants to important questions in domains like finance, medicine, science, and law. And with that, I'm happy to take your questions.